Okay, so in example 2, we're going to look at the image of a line under a rotation. Um, and let me just remind you that rotations from the book are mappings of the form multiplied by some fixed complex number, where that complex number has modulus 1. Modulus 1 means that A is on the circle, and this is not relevant for what we're about to do, but this means that A looks like cosine theta plus I sine theta, because it has modulus 1 for some whatever the argument of theta is. And we know that multiplying complex numbers corresponds to, well, multiplying their modulus. Well, that's not going to do anything to the modulus of z. And then adding their angles. Adding the argument from A to Z is just going to rotate Z by that A. So rotations, at least in the realm of complex numbers, are very simple functions. They're multiplying by a element of the unit circle, something of modulus 1, which is much more complicated if we were to use, if we were to think about C as R2, we have to involve 2 by 2 matrices, and it's just more complicated. Here, it's the complication is hidden within the complex numbers. Okay, so what rotation are we going to do? We're going to use the rotation, which is the following. It's going to be the multiply by root 2 over 2 plus I root 2 over 2 function. And our line, L, is going to be the real axis. All right, now if we think about this for a second, this is exactly cosine pi over 4 plus I sine pi over 4. So this is just e to the I pi over 4 times z. That's all that is. And we could sit here and we could parameterize the real axis and then figure out what happens, and that's perfectly okay. We're just going to rely on geometry for this problem. So here is our z-plane, and there's the real axis in the z-plane, and this is the function r of z, which multiplies by e to the I pi over 4, and multiplying by e to the I pi over 4 corresponds to rotating by the angle pi over 4. So here's r of L, we'll call that L prime. And then what is L prime? L prime, which is again r of L, is the line y equals x. Or the line real part of z is the imaginary part of z. Or the line t times e to the I pi over 4, where t is any real number. Because as t varies over all real numbers, you're going to get every point on this line here.